Inside the shadow of Geneva, under the world's floor, lies a shock of human inventiveness and a typical harbinger of obliteration. The huge Hadron Collider, LHC. It is a manual of keen assessment, allowing experts to inspect the subatomic at large and instigating the revelation of the bewildering God molecule, the Higgs boson. At this point, famous physicist Brian Cox has made a chilling announcement that sent shock waves all through the strict local area. Something critical has been investigated at CERN, something that may have achieved extended ways past our perception. Has our fundamental objective for illuminating informative combinations set us on an intense training with debacle, obliging us as we dive into the pit of this unmistakable issue? Yet, sooner than we bounce into the affirmation information, what sizable atom smasher peddles the tremendous LHC? Worked by using C, it is a 17M ring of superconducting magnets. Furthermore, the field's generally significant and by and large ridiculous strong particle smash. It addresses the pinnacle of human logical accomplishment. The reality of the circumstance is so strong that it would be able to imitate the certifiable states of the universe's creation. Should this development mean to open the insider appraisals of the universe, it remains aware of the way to something plainly more huge, potentially troublesome. CERN, spread out in 1954, is one of the world's generally basic logical examination relationships with 23 part states and an immense range of experts. It is a focal center for joint exertion and improvement. The LHC is CERN's central endeavor. However, it's simply one piece of an enormous organization of gas pedals and locators. This incorporates the LHC, which is intended for subatomic particles and is committed to the review of presence itself. The LHC speeds up protons to almost the speed of light, sending them on a crash course that mirrors the energy of the universe at the hour of the enormous detonation. The impacts create temperatures 1 million times more sweltering than the focal point of the sun. A monster cluster of magnets directs the protons on their way, while cutting-edge cooling frameworks keep up with the magnets at temperatures colder than space. These include 1,232 dipole magnets that steer the beams and 92 quadrupole magnets that center the bars before the crash. Another sort of magnet is utilized to pack the particles together to improve the probability of crashes. The errand of CERN is to impact particles with such precision that they meet exactly. The accuracy required is amazing. The LHC's plan is a wonder of designing, with parts packed very close. Along with arrangement accuracy estimated to within 574 feet, the whole framework is cooled to a temperature of 46 degrees Fahrenheit, colder than the vacuum of room itself. This cool climate is fundamental for the superconducting magnets to work ideally. The LHC's finders are situated at 4 areas around the gas pedal ring, relating to the areas of 4 significant molecule tests: Atlas, CMS, LHCb, and ALICE. Each plays a particular part in examining exceptional parts of molecule physical science. All in all, these identifiers catch huge amounts of information from molecule crashes. Experts then, at that point, filter through this information for proof of the slippery Higgs boson, otherwise called the God molecule, an uncommon oddity that holds hints to the universe's major structure. It's much the same as dealing with an unending jigsaw puzzle, where the pieces are undetectable and the image is challenging to recognize. By zeroing in on the microcosm, we gain bits of information about the universe. Yet, with each revelation comes new inquiries and challenges. The LHC isn't just a momentous logical instrument. It is an image of human interest, progress, and the journey to figure out the central powers of the universe. Anyway, as we stretch the limits of our insight, we should likewise think about the moral and existential inquiries that emerge. What are the dangers of testing the unexplored world? Should our mission for greatness suddenly release powers we can't control? Inside the consecrated corridors of CERN, where the outskirts of human understanding are persistently pushed, an ongoing disclosure has sent shudders down the spines of even the most prepared researchers. Brian Cox, a previous CERN scientist and a conspicuous voice in molecule physical science, has said something that has left mainstream researchers both enthralled and frightened. Cox's comments mirror an overwhelming chance. The LHC will likely reproduce a small, enormous detonation, an occasion that at first shaped our universe. The physicist likewise talked about the potential ramifications of this goal, featuring the LHC's ability to uncover new elements of understanding, counting bits of knowledge into dull matter, a substance that comprises a huge part of the universe. Examining the plausibility of seeing the real essence of the universe is an appealing opportunity, however one full of risk. Reproducing an enormous detonation isn't just hypothetical. It involves genuine conditions that recreate the universe's early stages. With such power comes real obligation and the requirement for cautious thought of likely dangers. Consider what is happening where something turns out badly. In 1978, Russian physicist Anatoly Bugorsky encountered a mishap that might have adjusted his life. While working at a high-energy physical science lab in Russia, a proton beam coincidentally passed through his skull, entering through the back of his head and leaving through his nose. In spite of this disastrous occasion, Bugorsky made do and proceeded with his work, in spite of the fact that he experienced some extreme medical problems. This occurrence isn't simply a story. However, it serves as a wake-up call, showing the colossal energy and potential risks related with molecule gas pedals. The dangers of molecule gas pedals like the LHC are not to be trifled with. The potential for uncommon responses and the control of crucial bits of insight require fastidious security conventions. Among the most disturbing potential outcomes is the production of little dark openings, locales of room where gravity is so extraordinary that not even light can escape. These theoretical substances could have unanticipated outcomes assuming they were to develop wildly. Notwithstanding broad well-being estimates, the chance of making a dark opening or other colorful peculiarities can't be totally precluded. Hypothetical models propose that any dark openings delivered would dissipate rapidly, representing no danger to Earth or its occupants. In any case, the very idea of possibly producing powers past our control remains agitating. As researchers push the limits of our understanding with the LHC, it is critical to do so with a careful consciousness of the related dangers and vulnerabilities. The quest for knowledge involves exploring these possible risks with straightforwardness and public commitment. The huge Hadron Collider, with its exceptional abilities and potential for historic revelations, remains as a demonstration of human inventiveness and the persistent mission for understanding. Anyway, underneath its noteworthy outside lies a space of significant logical request loaded with possible perils and moral contemplations. The tests led inside the collider include energies and powers outside the ability to understand of a great many people. The effect of subatomic particles at nearly the speed of light replicates conditions present in the universe's earliest minutes, permitting analysts to investigate central parts of issue and the actual texture of spacetime. While these examinations offer tremendous potential for disclosure, they likewise convey critical dangers, both referred to and obscure. Eventually, as we keep on investigating the mysteries of the universe through the LHC, it is fundamental to adjust our quest for knowledge with a profound consciousness of the potential results and a pledge to thorough well-being rehearses. One foundation on CERN and its exploration. CERN is a driving exploration community for molecule physical science. Its lead office is the huge Hadron Collider, LHC, the world's most impressive atom smasher. The LHC crushes protons and different particles together at close light velocities, permitting researchers to test the principal parts of issue. 2. Nature of unexpected revelations. Unexpected revelations in molecule material science could include new particles or peculiarities. Finding particles that were not anticipated by the standard model of molecule physical science, for instance, inconsistencies in the information could recommend new particles or, on the other hand, collaborations. Startling way of behaving of known particles could indicate new material science past the norm model, like supersymmetry or dull matter. Abnormalities in information and startling outcomes could likewise come from strange examples or estimations that challenge current understanding. 3. Brian Cox's commitment. Brian Cox, known for his capacity to make sense of complex logical ideas in an engaging way, would logically contextualize the revelations and make sense of what these new discoveries mean in the more extensive setting of physical science. How do these revelations fit into our current comprehension of the universe? Discuss suggestions and expound on how these discoveries could impact future examination. This could incorporate changes to hypothetical models or the plan of future investigations, connecting with the public and using clear, captivating language and similarities to make these disclosures open to a general crowd. For instances of past revelations, To give a feeling of the sort of surprising revelations that may be examined, here are a couple of historical models. Higgs boson. The Higgs boson, found in 2012, was a critical piece of the Standard Model. Its revelation was a critical amazement and affirmed the presence of the Higgs field, which gives particles mass. Antimatter. The revelation of antimatter and the way of behaving of particles like positrons, the antimatter-likeness electrons, has prompted critical advances in understanding the balance of the universe. Neutrino motions. Perceptions of neutrino motions, where neutrinos change type, provided proof that neutrinos have mass, which was excluded from the unique Standard Model. 5. Effect on future exploration. Unexpected disclosures frequently lead to new hypothetical models. These could propose new particles or powers that could make sense of the peculiarities. Further tests and extra analyses may be intended to investigate these unexpected revelations, propelling our insight into the universe. In summary, the LHC and the discoveries made at CERN serve as an extraordinary case of the extent of human inquisitiveness and the capability of science to push the limits of what we know. As we explore this perplexing universe and push the limits of our understanding, we should stay mindful of the significant obligations and dangers that accompany this quest for knowledge. The LHC is a demonstration of our mission for truth, the breaking of boundaries, and the intriguing adventure of understanding the universe that surrounds us.